Vinci and Soletange Bachy are committed to reducing the carbon footprint of their activities and construction sites. 10% of greenhouse gas emissions come from the construction sector. Concrete is a fundamental lever. It represents half of the greenhouse gases emissions effect in the construction sector. So how can we reduce the carbon impact of concrete? Cement holds a large part of the answer, as it only weighs 12% in the composition of concrete, but it is responsible for 98% of its carbon footprint. So to reduce greenhouse gas emissions related to concrete on your sites, take an interest in cement. How does cement work? Traditional cement, or Portland, is one of the components used in the concrete, along with water 8%, sand and gravels 80%. It is produced using limestone and clay. Such rocks are crushed together with other minerals, then they are dried and finally ground. This raw mixture is then put into the oven, where a flame that reaches 2000 degrees Celsius takes the material to 1500 degrees before suddenly being cooled down. After baking, clinker is obtained, which is the key material that will be ground again to obtain the cement powder. This cement manufacturing process is by its own responsible for between 7 and 8% of the world's total CO2 emissions. For you, which stage of cement manufacturing has the greatest carbon impact? Option 1. Raw material extraction. Option 2. The heating of the kiln that produces the clinker and the chemical reactions due to the decarbonization of the limestone. Option 3. Transport of limestone and clay. In different proportions, the three options emit CO2, but option 2 has the highest impact. The firing of clinker at 1500 degrees Celsius is responsible for about 40% of CO2 emissions, and while the chemical reactions that occur during firing represent 60%. What can we do at Soletange Bachy? Clinker is the main material in cement, and therefore in concrete, but its production results in very high greenhouse gas emissions. Good news! There is a solution. Okay, but how do we do that? Option 1. Prefer cement with smaller proportion of clinker. Option 2. Use alternative fuels in clinker firing. Option 3. No more use of concrete. The only way to reduce the CO2 emissions within our grasp is to reduce the amount of clinker used in the concrete. To achieve this, it is possible to blend cement substituting clinker with other alternative materials. Fly ash, blast furnace slag, silica fume, pozzolan, limestone fillers, metakaolin. These low clinker binders are already on the marketplace. Such cements are technically and economically viable. In the example already mentioned, you can see the equivalent of traditional Portland cement in other parts of the world. Therefore, at Soletange Bachy, to reduce the carbon footprint of our concrete, we can either choose these cements when we produce our mixes or ask our concrete suppliers to use them. And the impact reduction can make a huge difference in our carbon footprint. With an 85% reduction of clinker in cement, what would be the reduction of total CO2 emissions? Option 1. 20%. Option 2. 50%. Option 3. 75%. By choosing CEM3 Type C instead of conventional CEM1 Portland, concrete-related emissions would be reduced to 75%. And at Soletange Bachy, we already do it in a large number of construction sites all over the world. In Egypt, the Cairo Line 3 project and construction sites in Paris Metro Line 14 used a concrete with 40% substitution of clinker. The Forcefield site in Australia and the Thames Tideway site in London used concrete with 67% clinker substitution to produce diaphragm walls. On the recent projects in Dubai, a 40% substitution of clinker by slag and silica fumes was possible to achieve a high-performance concrete with strength over 50 megapascals. Like the examples mentioned before, we have many more to give you. Do you have ideas to reduce your concrete carbon footprint or how to use alternative cements? Contact Christophe Justino at the SB Materials Department or Juliette Lichard of the SB Quality Safety and Environment Department.